Alright, so to help with the studying for this test, I'm really just going to focus on the word problems, so there's only one video. And mostly I'm going to go over the ones that are on the study guide to hopefully guide you as you're studying tonight and tomorrow night for those in F block. So the problem says, find the dimensions of a rectangle having perimeter 14 meters and a diagonal of length 5 meters. So we know that the perimeter formula is 2x plus 2y is equal to 14, according to the problem. And then it says a diagonal of length 5 meters. And we know that rectangles have 90-degree angles, so the diagonal with one and then two sides of the rectangle add up to a triangle. So we're going to do Pythagoreans for our second equation. So it's going to be x squared plus y squared equals 25. And the way that I know this is where the problem wants us to go is, remember, we're working with systems with quadratic equations. So they want us to end up with one equation, or at least two of them, but at least one, that has a square in it. And then from here, I'm just going to solve. So I would solve for y in the first equation. So I get y is equal to 7 minus x. And then I'm going to plug that into my second. So I get x squared plus 7 minus x quantity squared equals 25. X squared plus 49 minus 14x plus x squared is equal to 25. So then 2x squared minus 14x plus 24 is equal to 0. This factors into 2x, x, and then minus 6 minus 4 equals 0. Yep, that adds up to 14. And so then we get that x is equal to 3 and 4. And if we plug that back in, if x equals 3, using this equation up here, y is equal to 7 minus 3, which is 4. And if x equals 4, y equals 7 minus 4, which is 3. So my dimensions are 3 meters by 4 meters. So then we get x squared plus 1,296 over x squared is equal to 75. Common denominator is x squared. So x to the fourth plus 1,296 is equal to 75x squared. Move the 75x squared to the other side. And then I just did the prime factorization of 1,296 to try and figure out my factors. And I see that 81 and 16 are both factors of 1,296, as well as I know that 48 and 27 go into 1,296, and those added together is 75. So my factors are going to be x squared minus 48 times x squared minus 27 equals 0. So x is equal to plus or minus the square root of 48 and plus or minus the square root of 27. But since we're working in measurements, we don't want the negatives. So 48 reduces to 4 root 3. And 27 reduces to 3 root 3. And so then if we plug those back in, if x is 4 root 3, y is 36 over 4 root 3, which is 9 over root 3, which is 3 root 3. And if x equals 3 root 3, y is 36 over 3 root 3, which is 12 over root 3, which is 4 root 3. So my dimensions are going to be 4 root 3 meters by 3 root 3 meters. Okay, the last one we're going to look at is, I believe, number 4, I think, on the worksheet. I'm not going to look at the one with the chemists because that was in the notes, and in the previous video. So if you do forget how to do that and set that balancing equation up, you can go ahead and skip to that video there. So the question says Sarah has $36 in $1, $5, and $10 bills. She has the same number of $5 bills as $10 bills, and she has 10 bills in all. How many bills of each denomination does she have? So let's take this piece by piece. The first sentence tells me that she's got $36 in $1, $5, and $10 bills. So let's name $1 X, $5 Y, and $10 Z. So then we've got X amount of bills of $1 bills times 5 times Y, $5 bills, plus 10 times Z has to be equal to $36 in total, right? She has the same number of $5 bills as $10 bills, so that means that Y has to be equal to Z. And she has 10 bills in all, so X plus Y plus Z equals 10. Okay, I'm going to rearrange that second equation, and I'm going to rearrange the entire system. Actually, I'm going to make this my new first. This is going to be my second, and this one down here is going to be my third. So I've got X plus Y plus Z equals 10. Y minus C is equal to 0. Sorry, that's my third. X plus 5Y plus 10Z is equal to 36. And Y minus C is equal to 0. I'm going to get rid of the X's in my second equation so that I can use it to solve with my third. So I'm going to take my first and transform by multiplying by a negative. And copy my second. The x's cancel. I get 4y plus 9z is equal to 26. Okay, and then I'm going to copy that into my system now. And I know a lot of you didn't like this method of organizing. That's fine. I just find that when I'm solving, it's easier to keep track of all of my equations and all of the variables if I continuously rewrite the equations over and over again. And a lot of people don't like that. That's okay. So then I'm going to get rid of the y's in my third equation. So I'm going to transform it by multiplying by a negative 4. So I'm going to copy my second as is. And then negative 4y plus 4z is equal to 0 because 4 times 0 is 0. The y's cancel if this would just mark. And then 13z is equal to 26. So z is 2. We got $2 there. Two $10 bills. And then we need to solve for y. But it said that we have the same number of $10 bills as we have $5 bills, so you know that y is equal to 2 as well, right? And then we take those two and plug it into the very first one. So x plus 2 equals 10. X equals 10 minus 4 equals 6. So in total, we've got 6 $1 bills, 2 $5 bills, and 2 $10 bills. And just to double check, 6 $1 bills is $6, 2 $5 bills is $10, so that's 16, and 2 $10 bills is 20. 16 plus 20 is $36, and so it works out. And that's my answer.